The 14th lecture of probability theory was the first lecture out of 2 dedicated to the Gaussian random variable. This is a very important variable which appears in many real-life examples ranging from physics, biology to finance and social sciences. We first give the definition of the Gaussian random variable by stating its probability density function, n, which is a function of 2 parameters, mu, the mean, and sigma squared, the variance of the Gaussian random variable. The Gaussian distribution has a typical shape of a bell shape centered about mu and having inflection points at plus and minus sigma with respect to mu. Without demonstrating it, we showed that the Gaussian random variable is a proper probability measure. That is, its probability density function satisfies the first and second Kolmogorov axioms. We then introduce a special case of Gaussian random variable where the mean mu is equal to 0 and the variance sigma squared is equal to 1. This is usually called the standard normal random variable, and it is the one sketched in figure 1. Finally, we showed how to relate the generic Gaussian cumulative distribution function to the cumulative distribution function capital Phi of the standard normal random variable, which is the only one tabulated in the statistical tables. This relation makes use of the introduction of a new random variable z, which is defined as the Gaussian random variable x minus its mean divided by the standard deviation sigma.